Hello my awesome viewers. In today's video we'll look into one of the water treatment methods which removes impurities and contaminants through a chemical process of adsorption, and this method is called the activated carbon filtration. Activated carbon, also known as the activated charcoal, is used to purify or filter out harmful substances from the wastewater. But first, what is wastewater? Wastewater is the water that has been used in homes or as part of the agricultural and industrial processes. The water itself contains physical, chemical, and biological pollutants that can pose danger to our environment. The activated carbon is able to purify water, but one of the issues that we are facing is that it is ineffective against heavy metals. Therefore, it is important to test and pre-treat the water in order to determine the substances that are present in water. Ladies and gentlemen, we have four types of activated carbons that we are going to discuss about in this slide. The first one being the granulated activated carbon. This form of a carbon is commonly used to dechlorinate the water and also absorb organic material. The second type that is mentioned in the slide, it is the pelletized activated carbon, which also dechlorinates the water and removes the chemicals. Then we have the powdered activated carbon, which is good for eliminating trace synthetic chemicals and can play a role in enhancing the taste and the odor of the water. Lastly, we have the catalytic activated carbon, which is used for removing chloramines from the water. In this slide, we are going to look into two properties of an activated carbon, which are surface area and pore volume. These mentioned characteristics are responsible for adsorptive properties which are used in liquid phase applications such as water treatment. Activated carbon consists of a variety of pores. These can be classified into micropores, mesopores, and macropores. The quality as well as the distribution of these pores determines the quality of any activated carbon. The large surface area of this activated carbon can be found useful in removing large contaminants from drinking and wastewater. In this topic, we will discuss two processes which purify or treat water, namely physical adsorption and chemical reaction process. The activated carbon used in filtration processes offers a broad range of pores in order to target a wide range of impurities. Generally, the larger pores target sediments as well as mineral impurities, whereas the smaller ones help remove bad taste and odor. The adsorption process is aided by the fact that all molecules have an attractive property. This property helps the material adhere to the carbon more readily. The carbon surface also carries a stronger attractive force than that of the impure water. Usually, organic impurities are more easily adsorbed. The only condition is that the contaminants must be smaller than the pore sizes available in the activated carbon. This condition is very important as the impurities will need to be trapped and accumulated inside these pores. Another way an activated carbon can remove impurities is through a chemical reaction process. This reaction is most commonly seen during chlorine filtration. During this process, the incoming chlorine simply reacts with the carbon to form chloride ions. This reaction thus helps separate chlorine from water to give pure water. In this part of the presentation, we will go through few advantages of an activated carbon. The first advantage is that the activated carbon can remove harmful contaminants. It is excellent for enhancing the taste and odor of the water. Activated carbon can be useful for filtering out organic and chemical disinfectants such as chlorine and other microorganisms in water. It is less expensive and therefore easy to maintain. Activated carbon can be used in small-scale and large-scale treatments. Here we have some of the disadvantages of an activated carbon. This activated carbon is not effective on heavy metals. It is also not effective on pathogens and viruses. Therefore, it is easy for the bacteria to form some growth in the water. Another thing is that some of the used activated carbon spent during the process cannot be regenerated, and this may result with land disposal issues. Activated carbon does not filter out hot water. It can only be exposed to cold water. This filter medium has a short lifespan and therefore needs replacement in a short period of time. Activated carbon is used in a variety of fields such as water treatment facilities. We can use it to separate gases and remove dyes from industrial wastewaters. We can use it also to remove solids from aqueous solutions. It is concluded that the activated charcoal offers one of the best and most effective means of removing contaminants in water. It does not only improve the taste and minimize health hazards, but it also protects other treatment units such as reverse osmosis membrane and ion exchange resins from possible damage or organic fouling. Activated charcoal is considered to be the best as it is harmless to human beings.
This brings us to the end of our presentation. The following students are the ones that conducted and compiled the research: Mokaba TC, Mwepe MM, Mokaba TM, Mujela C, and Mamabolo LE. And they are from the Department of Applied Science at the University of Johannesburg. Thanks for watching, and please don't forget to like our video. Thank you.